Okay, so in this video clip, I'm going to take a look here at American option pricing using analytical closed form solutions. We already have implemented Barone Adesi Whaley using C++ code in Microsoft Visual Studio. I'm going to repeat the same exercise, but in this instance, we're going to use OnlineGBD. So first thing here, we can download the zip file, and that'll go into our download. Now I've tried this also in incognito mode and it works. Okay, and from there we can go into our downloads. So I need to share with you the downloads. Now if we have here, let's take a look here at the Barone Adesi Whaley. Let's unzip that. We'll copy and we come back out and we can paste here. Okay, so they're now available as files that we can incorporate in. Okay, so we then go back to OnlineGBD. Right, so we open up the browser OnlineGBD, OnlineGBD, and we GBD, and we select the option here, language C++. We delete the code that's presented, the hello world print, and we can upload our files. So we need to go into the downloads, and we can do this one by one. So open, and then we go again. Again, keep in mind that there are 6 files here, and they load up nicely. Now we've also to designate the main CPP, and we'll do that in a moment. So for the moment, we don't really have a proper main file. We've got to select which of the CCP files is main. So black shows that's a source file, and we upload again. And so we're doing this, each of these individually. And then the last one here is structures.h. Structures.h. So that's a header file. Okay, now when we go through here, we have Barone Adesi Whaley. The first one in the sequence looks like the main file because in effect we have, that's where we have output here, right? So we need to make one change then. Just copy this segment of code, copy, and then we'll paste that into the main, and then we'll delete the Barone Adesi Whaley approximation. Keeping in mind the code now appears here with this main CPP. Okay, so it should be, we're ready to go. It's again, the source of the file is Fabrice Roua, and this was on the original Volupta file that was a repository set up by Fabrice. Okay, so let's just run and see what happens. Okay, see what output we get. And there is some issues here, so we need to. Okay, so if you look at in the debug menu, debug window here, we can see that it's the std-afx, which is presenting issues. Okay, so I think if we ignore it, if we won't delete, if we just neutralize it by putting the double forward slash here and see where references to that, including those files. Okay, so we just remove them. Normally that seems to resolve. Okay, and let's run again and see what output we get. Okay, and we get some output here, and this is Barone Adesi Whaley approximation to American options. Okay, so we get a range of values here, and we seem to have an implementation. Now, just one word in terms of the we have in the Black-Scholes CPP source file, we've used this WASI and ROSA normal cumulative probability function, cumulative density function. It's an approximation. It's not hugely accurate. It is fast. I think that's why Fabrice would have used this. We could use a bool function, which would be much more efficient. Okay, so I'm going to leave it there. The main objective here was really to introduce, if we do have zip files with a number of source and header files and a main, how do we load that into OnlineGBD in a relatively efficient manner? And this upload file here is quite an efficient way of doing that.